Welcome all. Let me say, just a minute. Find single premium. We are finding single premium. This we have already done. This is not new. So we'll write equation of value here and we'll do that. In addition to this, if I write here expense means the total expense at time 0, that is 10,000 for this kind of a policy. Then find the single premium. This is next question. Find an expression. Let me write the equation of value. Expected present value of income. Only one premium, that is P. That is expected present value of outgo. 30,000 here. So you write sum assured here, then AX 40 A40. Here I left one thing, basis, okay, interest rate in the market and how you will find it. Normally we write M92 mortality and interest rate is suppose 4%. Then you see the table 4% and A40 you need to see here. A40 at 4% is 0.23056. This one 40 here 0.23056. This is over. Here this one, if you write equation of value, same EPV of income, EPV of outgo we have to write. Apart from that, we need to add expense to one side. Which side you need to decide. Suppose here EPV of income, I'll not change. We'll change it later when you divide the premiums into monthly or quarterly or maybe every 15 days, then we'll divide. Now it's one-time premium, we'll not divide. And this is the only source of income for the insurance company. So income will not be more if you add something, because this is an expense. When you are balancing in the left hand side, as I already mentioned you, the only source of income is premium income. So this side will not change anymore. Here we have to add. This is a form of outgo for the company. This is also outgo for the company. Find the value of P here. That's all. So if there is an expense, it will come later. We have just started now. So in the basic form, we have started with this expected present value of income is equal to expected present value of outgo. With that assumption, we are trying to do the initial problems, but if expenses will come, then you have to add to the right hand side. Now write an expression for X. We'll elaborate this one today. This is a recap. We know already Pxk, Qx plus K. There is another notation. We write K deferred Qx. You can write this one as well. Suppose the policy type is endowment. And here age, let's fix at 40. Term will be there, though it's not a term assurance. Endowment means it's for a fixed term. Suppose 20. Sum assured we have to write same 30,000. And when benefit is paid, that we have to write. Along with all this, we have to write the assumptions called basis. What table you are using, M92, and what interest rate. So here benefit is payable at the end of year of death. This is also something you need to check. For the time being, we'll consider benefit to be paid at the end of the year of death. Under this, you need to find the premium. In the equation of value, let me write. Okay, this side I wrote income, no problem. Here, because this is an endowment assurance. This is an endowment assurance. You have to write sum assured anyway, that will be the coefficient. and you have to write AXN. Remember, this is for whole life, this is for endowment, this is for term 1 here, and this is for pure endowment. So this is for whole life, this is for endowment, it's valued only for term n years. However, you have a benefit, you have both benefits, survival benefit as well as death benefit here. And this one is term. Term means only death benefit, here only survival benefit 1 here. If you add these two, you will get this one. This plus this will give you 2. 2 is 3 plus 4. This we know. Here, because this is an endowment assurance, we have to write this AXN. X is the present age 40 and this is 20. A 40 20 you need to write. So P is equal to 30,000, and here at 4% you need to see the table A 40 20 AXN given, but it's not given for all values of X and N. N is always 60 minus X. Even you have a page where you will get 65 minus X. So if X plus N is 60 or 65, then only you have value. For example, I've taken 40 here. X is 40 fixed. So if you see this one, AX and this column, this row, this column intersection, they meet at 0.46433. So 0.46433 is the value for AXN. What is X? X is mentioned here 40. We have taken 40th row. What is N here? N is 60 minus X. 60 minus 40. That is 20. That means if you take X this side, irrespective of whether you are taking 17, 18, 19, 20, 21, 22, whatever, N plus X will always be equal to 60. You take X that side, left side, and you add with N. If you see, N plus X will be 60. So if this is 30, automatically, if X is 30 here, you put 30, N will be 30. So A 30, 30 if you want to find, you see this row. So you need to check only X. Why N is fixed here? How? Because N plus X should be always 60. So my value will be 40, 20 value, 0.46433. We have to multiply to find the value. Remember, here, if it's 40, then it should be 20. Then only you will be able to see the page I showed you. If it's 50, it should be 10. Because in each case, X plus N is 60 and X is or N is always 60 minus X. So it will depend on the first one. For a given value of X like 50, N will be the second one, 60 minus X. So 60 minus 50 is 10. So if it's 59, it should be 1. Then only you can see that page. Also, there is another page where you will find this way, 65. Okay. So if it's 40, it's 25. If it's 45, then this would be 20. If this is 60, then this would be 5. That one. X plus N will be 65 always. Here, here, here you check. So that page, if you want to see, N will be 65 minus X. Only for these two values, you will be able to see the table and write it. Otherwise, you will not be able to use the table. See, 65 minus X. So this is over. And let me tell you, this you have to see table mostly. Mostly I'm saying. Almost all the time. AXN, see the table whenever possible. In the cases where X plus N is either 60 or 65. Otherwise, we'll have other thing. Okay, we'll go to that later. Otherwise, we'll find a way later. Okay, now for the time being, you can see the table here, here. This is pure endowment. This is term assurance, not given in the table. Remember, these are not listed in the table, not given in the table. Remember now, not given in the table. However, if you see AXN, pure endowment, not given in the table, same, not given in the table. However, this value you can directly find. There is a formula. Don't worry about the derivation. Remember, this is Px and Vn. So out of all these four, out of four, your formula only for one. Okay, only for this you have a formula. Let me write this. This is the formula. Remember now, we'll discuss logically, we'll discuss mathematical later. This is the formula. This formula is only for this one, pure endowment. This one you have to see the table. This one you need to see the table. For this one you need to find it out. Not given in the table. The formula is like this. What I wanted to say is you have to see this from the table anyway. So you have to see the table for this anyway and this anyway. So even if there is a formula for this, you need to depend on the table. So see, everywhere for all these things, you are dependent. You need to see the table. This is the only term where you have to find using a calculator. Here also you need to see the table for Pxn. But you multiply Vn, you get the answer. So there is a mathematical formula. So you can say there is a formula for this, there is a formula for this. Here you are totally dependent on the assurance function, Ax, at least, if not for other reason. But here you have a formula. You can't use a formula to find this. You have to see the table. You see the table, this one here also you have to see the table. You multiply Vn using calculator, then you will be able to know this. So this is pure endowment. So how you can find term? Either you can use this formula, or the second alternative is, if you are evaluating a term assurance, there are two ways. The first one is this, and the second alternative is you subtract this one from this one. So this one will be equal to, this formula is there. Okay, anyway, you can express the difference between two whole life assurances. Here we will write Xn, because this one plus this one is this one. This is endowment, that is equal to term plus pure endowment. So you can subtract this one from this, minus Axn1. So for this you can see that we can use the formula, evaluate this. So this is known, and then this given in the table, at least for these values, and then subtract, then you will get this one. Normally we use this formula, this one. This is not a formula, this is obvious. This is by the mathematical equality. If you add term and pure endowment, you should get endowment. From that you get this one, but this is a formula, we'll derive later. So if you ask me when to use what, if X plus N is 60 or 65, this you can get from the table. So this you know, and this you always know. So subtract and find the value. If X plus N is not 60 or 65, you have to use the formula, this formula, and then find it. You might ask me a question saying that if X plus N is not 60 or 65, even X plus N is 60 or 65, suppose I write a 40 20 here. So a 40 20, for this also you can use this formula. Obviously you can write a 40 minus p 40 20 v 20 a 60. So both whole life assurances are available in the table. You can put, you can find the value, that's fine. Even for these values also you can use this formula. This formula you can use every time, there is no problem. However, if you use this formula, you will be able to evaluate easily. You can save time. So if X plus N is 60 or 65, you use this formula. Here you save time. It's very easy. Here, how many times you need to see the table? For this you need to see the table once. For this one you need to see the table once. And this you need to see the table. You have to multiply with a calculator. You multiply with it, subtract. It takes time. Even you say, no, how it will make the difference? Anyway, this takes 10 seconds. This will take 20 seconds. But remember, I'm not talking about evaluating these values. In a problem, okay, you will get a 15 marks problem or 20 marks problem tomorrow in the exam. So there you have to evaluate these terms maybe 10 times. There it will make the difference, not now. Term assurance, age is given, sum assured is given, and basis the assumptions, AM92 mortality, 4% per annum interest. Because 20 plus 40 is 60, we'll write here equation of value expected present value of income is equal to expected present value of outgo. Income is P only, and here outgo is 30,000, and here you need to write a 40 20 1 here. So P is a 40 20 minus a 40 20. This is pure endowment. So from the endowment, we are subtracting the pure endowment, the survival part. You will get the term or the death part here into 30,000. Now, as I mentioned you earlier, this one you can see the table we found already, 0.46433 minus. For this you need to use the formula, AXN formula, PXNVN. So P40 20 V20. So this is L60 divided by L40 into V20. So you calculate using a calculator what is the value of V20. Even V20 you get from the table for some interest rates, not all interest rates. L60, L40 you need to see the table. You find the whole value. That's all you put here, and you multiply 30,000. Now suppose I change it to 41. Just change this to 41. Then what will happen? And then you can't use that formula because endowment is given when x plus n is 60. So you don't get the endowment part. And these are anyway not given in the table. If you see here, these are not given in the table. One here or here, these are not given. The pure part you can use the formula. For the other part you have to subtract from the endowment part. So here you can use this formula. Let me write the formula here. That will be x minus pxn vn ax plus n. And for this we'll not take the help of that one endowment minus pure endowment. Directly we have the formula for term. P is equal to A41 minus P41 20 V20 then A61. This you see from the table. This you see from the table. This also you see from the table. This is L61 divided by L41. This is also table, and you can multiply this using calculator. That's all. So you can do this way. Now I'm changing this one. The next question is, you do it when this is endowment. Then how can you find? Who can answer? First of all, let me clear this. And now it will be A4120. But there is no formula for AXN. There is a formula for AXN1. For term, there is a formula. For endowment, there is no formula. You have to see the table and find. Then how can you solve this problem? We have to erase it, okay? Otherwise, it will not look clear. Continue here. So you are saying, let me divide this one now. Term here. This way. Then you multiply 30,000. And for this one, we'll use the formula. 4120. No change. A41 minus P4120 V20 A61. Whatever value this you get, you can write here. Term part already you found. Now for this one, you can use the formula PXN VN. P4120 V20. You can write. Then you can multiply by 30,000. So this is your P. Whatever you get, you can write here. This will be the answer. Now let me write another question. Suppose this is term assurance, and term is for 3 years. Age is 40. Sum assured 30,000. Again payable at the end of year of death. Then basis, interest rate is 4%. Mortality, 1% every year. See here, there is no reference to M92 mortality. This is 4% or 6%, 5%, whatever given. Okay, but this is 1% every year. Otherwise, I can make this way. Suppose mortality will make M92, but this one will make it 5%. Then what will happen? Suppose this is 5%. Mortality, you can see M92 table. So PQ, you can see the table, but interest rate is no more 4 or 6%. You know, for 4 or 6%, you see left-hand side, all the values are given at 4% or 6%. See here, left-hand side. However, in this question here, 5% is given. So you can see the table. Without seeing the table, how can you solve the problem? That is the question now. Let me write equation of value. Expected present value of income is equal to expected present value of outgo. Expected present value of income here is P. Expected present value of outgo 30,000. 43, it's a term, so we'll write a 1 here. Now there is no other way to find apart from your complete expression. You have to open this one. So now you need to know the formula. You must be knowing, last time I discussed about the formula. A40, let me write Q40 into V. This is one term plus P41 Q41 into V square. 3 terms we need to write. He might die within the first year, 40 to 41, or survive 1 year, then he will die. Then let me write P42 Q42 V power 3. Here P will be 30,000 into. Now the V's you can find using 5%, and for the Q, P, whatever is here, you can use mortality. But you can't use mortality for this one. Even if you transfer it to endowment or any such formula, this is not allowed. That you need to remember. Now the last question. Here I will change it to a fixed mortality for the time being. Later we can change it. Suppose mortality is 1% or 2%, whatever. 1% people will die. This is also high mortality. In this case also, you have to write this way. And 5% anyway, here you can use 4% or 5%, it doesn't matter. You can see the table anyway. You will not see table for anything now. So even Q40, you have to find using this 1% mortality at each age. Let me write. So what will happen? Q40 is 1%. Q41 is 1%. Q42 is 1%, that way. Otherwise, I can give you a formula. for Q40, Q41, Q42 separately. Instead of writing 1%, I can write 1, 2, 3%, whatever I want. Here all are 1%. So what you need here, Q40, that is available here. P41, P41, 41 is 1 minus Q40. So Q40, you know, given. So you know P40. Q41 is given here. So you put here, you know this one now. And this is P42. Q42 is here. And what is P42? P42, you have to write it this way, P41, P41, 1. That is P40 into P41. 1 minus Q40, Q40. That way you can write. So whatever is required, you can use. And then you can find the values and you can put here. Now you will be able to solve the assignment. I'll send you one assignment. You do that. We'll continue next time. Class is over for today. Thank you. If you have any doubt, you can ask me now on whatever I taught you today. No doubt? Okay. All right then. Thank you.
Thank you, sir.
Okay, fine. Thank you.